Sorry. Thank you. Yes, I will just say a few words of INRIA, which is a National Institute for Research in Computer Science and Applied Mathematics. So it's a nationwide institute which has branches in many cities, and it has two branches in Paris. One in the center of Paris, which is close to Gare de Lyon, and another one close to École Polytechnique in the south of Paris, right? So what I will describe a bit more precisely is the activities that we have at INRIA through the ERC program at links. So this is this NEMO ERC program. This program started 3 years ago and will last for 3 more years. And it's a joint program between, you know, possibly how things are organized at ERC. There are panels. There is a panel on, say, communication sciences, which is P7, and another one on mathematics, which is P1. And so this program was submitted as an interdisciplinary project across the 2 panels, mathematics and communications, which is okay. So that's the general framework. So roughly one of these programs is, so these are not huge programs, right? But they're quite well organized. I think ERC is a very nice structure. We have in the program 5 PhD students. There are 5 years of postdocs and one so-called starting research position over 5 years. So it allows really to do something which is not grand scale, but quite sizable and quite nice. I think it's one of the very nice European programs. And so Jean-Pierre Bourguignon, who launched the structure and pushed it and did a lot to move from the purely collaborative things where you have 12 partners in many countries to this individual grants. I think it's compared to international standards in research in the US and elsewhere in the world, it's really a great program. Bourguignon did fantastic things in this setting. Okay, so let me tell you a little bit about the topics. So let me start with the P7 type activity. And so although the 2 things are very much linked, the P1 and P7 activities, meaning math and communication. So the general framework is about dynamics of networks. And for the communication part, the activities in core 5G topics, beamforming, bandwidth part. Now starting with the 6G direction. This is pretty much in strong collaboration with Bell Labs. There is a very strong standard group there and very nice researchers with whom we have excellent interactions. The second activity is on vehicular networks. And so you heard, I mean, this is mostly in collaboration with Chang-Sik, you heard, and Gustavo. Some of you know Gustavo de Veciana in UT Austin. So in particular, he has lots of interactions with India, right? And the third topic is about really, I mean, dynamics. I mean, either user motion or queuing dynamics in the. So typically, you're familiar with all these problems in stochastic geometry where we do spatial averages, but the interesting thing is to add time dynamics on this. On these spatial things, right? And this is quite challenging, and so we have a line of thought with both UT Austin and Pierre Popino is working on these topics. So this is quite active too, and a very different line of thoughts. Okay. now let me move to P1 and describe a little bit what we do. So it's perhaps a bit more remote from what I listed earlier. So it's really math. So the main activity, main two activities are on unimodular random graphs. So unimodularity looks something frightening, but it is just an extension of Palm calculus, right? You've seen yesterday in the beautiful lectures of Martin and Harpreet and Changsik how important was Palm calculus. I mean, the Palm calculus in this setting of road networks is this additional road on which the user is, right? So this is the biasing that the observer creates. If you are on a road, there is a road on which you are, and this creates a biasing of the statistical observer, right? Okay, and so this has extensions beyond the Euclidean spaces, so you can do that on graphs, and it's called unimodular random graphs. It's developing very fast. It's a beautiful topic. So. And we hired Ali Kezeli from Sharif with us as this starting research position working on this topic. And the second one is on point processes. So it's more classical, but we have lots of activities, especially in high dimensional. There are nice connection with stochastic geometry and the information theory and the compressive sensing and the data science that we are pushing, and this is a completely different line of thoughts on high dimensional objects. Okay, so that's what I wanted to say. And now, unless you have questions on this, I would give the floor to the technical program.
Thank you.